Hello physical science students, and welcome to this video about radio communication. We're going to look at radio transmissions, analog versus digital signals, telephones, and communications satellites. So you know that signals and information can be transmitted using radio waves and microwaves. You may have noticed, if you've ever listened to a radio, that the radio station is labeled with a number. Those just aren't any random numbers. They actually represent the frequency of the radio wave that particular station broadcasts. We call an electromagnetic wave with that specific frequency that it is assigned to a station a carrier wave. It has a very specific, very specific frequency. Modulation is the electrical signal that modifies this carrier wave. So the station has to do more than simply transmit their carrier wave. They also have to send information about the sounds, and the sounds produced at the radio station are converted into these electrical signals, and those are what modify that carrier wave. That is called modulation. There are two different ways that carrier waves can be modulated. We have amplitude modulation, that's AM, and we have frequency modulation, that's FM. So amplitude modulation varies the amplitude of the carrier wave. Frequency modulation varies the frequency of a carrier wave. Here, if you think about the carrier wave and the signal, here is amplitude modulated wave, and here is a frequency modulated wave. So if we compare these two ways of modulation, you can see that for frequency modulated waves, the strength of that wave is kept fixed because the amplitude is not being modulated. And so that is why a lot of times FM signals tend to be clearer than AM signals. So how does this all fit together? How do I end up getting my music coming out of my radio? Well, first, the radio station transmits this modified carrier wave, and then the modified carrier wave is converted from an electrical signal to a radio wave via a large antenna like this one. In a broadcast antenna, the vibrating electrons produce an electromagnetic wave that travels outward in all directions from this antenna. Those electromagnetic waves end up passing by your radio's antenna, like this one, and then that causes electrons in the metal to vibrate, which produces changing electric current. It causes your speakers to vibrate, which creates the sound that you hear. Now let's take a look at something called analog signals and digital signals. Analog signals are basically electric signals whose values change very smoothly over time. Examples of analog signals are the AM and the FM radio. Television used to use the FM audio for audio information and the AM for the visual information on the television. However, since 2009, all full-power television stations in the United States began broadcasting only digital signals. And what are digital signals? Basically, those are electric signals with only two possible values, on or off. And this may sound very limiting, but there are actually many ways to modulate radio waves using the on and off information. The simplest methods kind of resemble the AM and FM modulation. We call them amplitude shift keying and frequency shift keying. They're shown in these diagrams. More complex ways of digital modulation allow more information to be carried by a single wave. And in the United States, our television stations use multiple amplitude modulations to encode the data on the carrier wave. Now let's talk a little bit about telephones. A cell phone is basically a transceiver. What's a transceiver? It transmits one radio signal and receives another. Using two signals with different frequencies allows you to talk and listen at the same time without interference. Otherwise, you would not be able to do that. Cordless phones are also transceivers. However, you have to be fairly close to the base of a cordless phone. And another drawback is that sometimes if someone nearby is using a cordless phone at the same frequency, you might hear their conversation on your phone. That's why cordless phones often have a channel button that allows you to switch to another frequency. Pagers are radio receivers, not transceivers. Sometimes hospital facilities ban cell phones, the transceivers, because of a concern that they will interfere with medical equipment. So oftentimes doctors will carry small pagers. They are only radio receivers. And so the pager receives messages transmitted at its assigned frequency, and then it only responds to messages with its identification number. The doctor would have to use a telephone to call the person back. Restaurants sometimes use pagers to notify customers that their tables are ready. And last, we cannot forget about communication satellites. Communication satellites are transceivers. We see their application with satellite telephones. They can be used even when you're flying across the Pacific Ocean because they are communicating with the communication satellites. Here's a picture of a communication satellite. Satellite reception dishes allow for television, satellite television. Communication satellites typically use microwaves rather than radio waves because microwaves have shorter wavelengths and they can travel more easily through the atmosphere and more quickly. The ground receivers are dish-shaped to help basically focus those microwaves onto an antenna. And last, we of course need to mention the Global Positioning System, or GPS. It is a system of 24 satellites that became fully operational in 1995. They help to determine your exact location at or above the Earth's surface. They're basically owned and operated by the U.S. Department of Defense, but the microwave signals that they send out can be used by anyone. Advanced ideas? Try some of these, or if you have your own questions, ask your own questions, come in, do a little research. I look forward to seeing you in class and seeing what you have to come up with.